Welcome back. In our last lecture, we explored the mutable set type. Now, we introduce its immutable counterpart, the frozen set. This special type combines the uniqueness of a set with the safety of immutability, similar to how tuples relate to lists. 1. Creating a frozen set. You create a frozen set using the built-in frozen set function, passing any iterable, like a list, tuple, or an existing set, as an argument. Like regular sets, the frozen set automatically removes duplicates upon creation, and the order of elements is not guaranteed. 2. Immutability in action. Because frozen sets are immutable, they do not have methods that change their content, such as add, remove, or discard. Attempting to use them will result in an attribute error. 3. Primary use case. Dictionary keys. The main reason for the existence of frozen sets is that they are hashable due to their immutability. This makes them suitable for use as keys in dictionaries or as elements within a regular set, which mutable sets cannot do. To summarize, use the frozen set function to create a fixed collection of unique items. Its immutability ensures safety and allows it to be used as a key in mapping data structures. We have covered lists, tuples, sets, and frozen sets. Up next, we'll explore another built-in sequence that generates numbers, the range type. Join me in Lecture 0 Fort 16. Range type.